Okay, this says a parametric curve is defined by x equals sine of t and y equals cosecant of t on the interval 0 to pi over 2. And then we have to describe what this curve is doing. Well, so to determine whether it's increasing or decreasing, we need the first derivative. So dy dx. So recall that in parametric, that's dy dt divided by dx dt. So dy dt would be the derivative of cosecant, which is negative cosecant t cotangent of t. And then the derivative of dx dt would be the derivative of sine. So we have, and so we got to evaluate this on the interval 0 to pi over 2. So you can kind of use the fact that the behavior must not change on that interval. Otherwise, they couldn't be asking this question to begin with. So we should maybe plug in a number like pi over 4, and then just see if it's, well, I don't want to write that, but we're going to plug in pi over 4 and then see whether it's positive or negative, and that should tell us the increasing, decreasing part. So this would be negative cosecant of pi over 4 times cotangent of pi over 4 divided by cosine of pi over 4. Okay, the only thing we really care about is whether this is positive or negative. So it's going to be, pi over 4 is in quadrant 1. All the trig functions are positive, but this negative is going to make it negative. So it should be negative. If you're curious what it actually is, cosecant of pi over 4 is root 2, so we get negative root 2. The cotangent of pi over 4 is 1, and the cosine of pi over 4 is 1 over root 2. And so you get, in the end, negative 2. But in any case, it's negative, so that tells us it's decreasing, which means that's out and that's out. Okay, now the concavity question, this is where we have to use the second derivative in parametric. So that looks like, remember, it's going to be the derivative with respect to t of dy dx, which is the thing we just found above, divided by dx dt. Now before I go ahead and take the derivative of this thing, this is where it can save you some time if maybe you use a couple of trig identities. Maybe that can be simplified, and that way it won't be such a headache to take its derivative. So let's see if I can do that. So that's equal to, let's do it over here, maybe just off to the side. So I got negative cosecant of t times cotangent of t divided by cosine of t. I actually could have done this too when I was evaluating, by the way. So this is negative 1 over sine of t. Cotangent is cosine t over sine of t. And I'm timesing that all by 1 over cosine. Or dividing by cosine, but that's the same as this. So that divides out. Okay, so a little bit better, because I can now write that's equal to, this is the same as negative 1 over sine squared, which also we could call negative cosecant squared. So maybe a little better, so just a little easier to work with. Okay, so this is going to be, so the derivative of negative cosecant squared divided by dx dt, we already found that's cosine of t. Okay, so the derivative of the numerator by the chain rule is negative 2 cosecant of t, and then times the derivative of cosecant, which is cosecant of t cotangent of t. All that divided by cosine of t. And again, maybe we can clean up a little bit. We'll see. So it's positive 2 cosecant squared t times cotangent divided by cosine t. Now again, if you're clever, we can know what's going to happen on the interval 0 to pi over 2, because again, if I plug in pi over 4 for t, Okay, just all along the way here. Okay, evaluating this at pi over 4. Again, squaring something always becomes positive. That's positive. Cotangent of pi over 4 from above we know is positive. So now I've got like a positive, a positive. So I'm not even evaluating in cosine of pi over 4. So it's going to be positive. So I'm just going to write positive because we don't really care. We don't really care. We don't really care what it is as long as we know it's positive. So I'm just going to put that. So that must mean it's concave. That means it's concave up. Okay, so just to be kind of, I'm like quasi-thorough, but not totally thorough. So we know the second derivative is positive, so we just concave up. So we were looking for concave, decreasing concave up, and that's letter C.